All right. So we're going to talk about inscribed quadrilaterals. So let's get going on this one. So we're still talking about circles, but just kind of changing a little bit of how we use some of the things that we already know. So an inscribed quadrilateral is a quadrilateral, four-sided polygon that's inside this circle. So let's backtrack just a little bit. We know that the interior angle sum of a quadrilateral is n minus 2 times 180. So in this case, because it's a quadrilateral, n is equal to 4, 4 minus 2 is 2, 2 times 180 is 360. Okay. So we can use that to figure out on any quadrilateral different measures. So on this one, we could say that the angle A plus 138 plus 138 plus this angle 8x plus 10 has to equal 360. Then we can solve for x. Same thing with this one. We could say that all of these angles have to add up to be 360 degrees. So this one has to be 90. So I could say 14x plus 6 equals 90. And then I could solve for x. So an inscribed quadrilateral, when it's inscribed, it's inside the circle, and all of the corners of the quadrilateral are on the circle itself. And if it's inscribed, then the opposite angles are going to be supplementary. That means they're going to add up to equal 180 degrees. So if I've got an inscribed quadrilateral, and I have angle 117 degrees, and I'm looking for the angle that's opposite it, then I can say that those two angles add up to equal 180 degrees. Then if I subtract the 117 from each side, I can figure out that this angle over here is 63 degrees. Now on this one, we're going to have to use that the inscribed angle theorem. So I have this unknown angle, angle P, and its intercepted arc is arc MNO. So I can then say, all right, if that's the intercepted arc, then whatever that arc is, I can cut it in half, and that's going to be angle P. So 62 plus the 98 degrees equals 160 degrees. And I cut that in half, and that tells me that's this angle is 80 degrees. So I was adding those arcs together to get that entire intercepted arc, and then cutting it in half to get angle P. All right, so on this one, we've got variables involved. So angle A is 11x minus 2, and we've got 5x plus 6 for angle C. These are opposite angles, so we know that they should add up to equal 180 degrees. So I'm going to set those, adding those each up to equal 180 degrees. And then I combine my like terms, and then I solve for x, and I can figure out x is 11. So now that I know that x is 11, I'm going to be able to substitute that back in and then be able to figure out what each of those angles are. So I'm going to use angle A. So I substitute that back in for x, and angle A is 11 times 11 minus 2. So it's going to be 119 degrees. So now I know that angle A is 119 degrees. Now if I look at that inscribed angle, the intercepted arc is DCB. All right, so arc DCB is the intercepted arc for angle A. So I can say if I multiply this arc or this inscribed angle by 2, then that's going to be the same as that intercepted arc. So if I do 119, because I know that's angle A now, times 2, then that's that whole big arc, that major arc, DCB. And a major arc is just an arc that's bigger than 180 degrees. So I know that that arc is 238 degrees. So if the whole circle is 360, I just have to subtract the 238 degrees, and that tells me that the minor arc, DB, is 122 degrees. Okay, and you could have used this one over here to figure that out as well. If I had substituted x equals 11 into here, and then just multiplied that by 2, that would give you this part. But I also wanted to show you that there's more than one way. All right, so now on this one, we've got a couple of different things. We only have one angle inside, and inside our inscribed quadrilateral. But I'm going to look at that intercepted arc. Okay, so our intercepted arc is RST, the major arc RST. So now I can say, all right, if I take this, multiplying it by 2, that's going to equal that major arc. And I distribute, combine like terms, and solve for x, and I can figure out that x is 19.5. Okay. Now, I can say, all right, if that's 19.5, I can substitute this in for x and figure out that the arc, the measure of the arc TS is 158 degrees. I'm hoping that that is helpful for you guys when you're looking at inscribed quadrilaterals.